Welcome to our Friday video. So we have talked about different charts that we can use to present data. And specifically we've talked about categorical variables, and we use either a pie chart or a bar chart. We've talked about quantitative variables, and we saw that by hand you can make a stem and leaf plot, or you can have Excel make you a histogram. Both of those are charts that we use to see the shape of a distribution of a quantitative variable. So we've hit a bunch of the main charts. Here's my dog Teddy saying hi. You like charts, right? I think he only cares about charts if they show the number of dog treats that he gets. Would be a quantitative variable, right? Which kind of dog treat? That would be categorical. So there's one more chart we're going to learn, and this kind of gives us a nice segue into our next section, which is talking more about where a distribution for a quantitative variable is. So we're building off what we've done with histograms or stem and leaf plots, thinking about a distribution of a quantitative variable. So I've got a little bit of data on the number of Valentines that different kids got. You can't really see, but that's okay. I just made up some numbers. And so you'll see it's like 14, 18, 17, 20, 15, 15, 16, 22, 19, 13, and 15. So we've got 11 observations here. The first thing we want to do is I'm going to put them in order from smallest to largest. So I'm just going to rewrite them. So it was 13, 14, 15. I'm going to cross them off as I write them. So 15, we've got 3 of those. We've got a 16, 17, 19, and then 20, 22. So same numbers, I just put them in order from smallest to largest. Now, what we're going to do is we're going to talk about a distribution for these. We know if there were a histogram or a stem and leaf that we would have a plot that would include those smallest value all the way up to the largest value, so 13 to 22, 12, 14, 20. We would draw bars, how many fit within each of those bins, or Excel would actually do it for you. So we know we'd be operating on this part of the number line. That's where our distribution is located. Now, what I actually want us to do is think about some numbers we can use to describe where a distribution is. Again, this is getting us into this more number-oriented analysis as opposed to just drawing pictures. But so first we're going to learn a few concepts. We're going to talk about a min and a max. That's easy enough, right? The min is the smallest number that we have in our data set, and we've put them in order already, so that's easy. We look, and that's a 13. Our max is the largest number in our data set. Again, we've already put them in order, so we can just look at that and say, aha, the biggest one is a 22. Now, you guys are probably familiar with the term median. If we put our terms in order, the one that's in the middle. So here we have 11 observations, so that means the 6th one has 5 below it and 5 above it. 4, 5, 6, 7, 8, 9, 10. I have 10 there. I missed an 18 when I was writing these out. So the 6th number has 5 below it, 5 above it. And so that is our median. When we put the numbers all in order, the one that is right in the middle, equal number of observations above and below, that's our median. I drew a little arrow above it. Now, what if you have an even number of observations in your data set? Then there's no number that you can look at that has an equal number of observations below and above it. So if you have an even number of observations in your data set, you take the two middle numbers and you take the average of them. So if we had one more big observation here that was 20 something, then our middle numbers would be 16 and 17. So we would say our median is actually 16 and a half. The average of those two, add them up, divide by 2. Now, when we put all our numbers in order, we can also think about a number within the data set that has 25% of the data below it. We call that a 25th percentile. Percentile is a way to describe something that has whatever number percent of the observations have a value lower than that in your data set. So the 25th percentile has a quarter of the data below it. So here, so the median is a 50th percentile. To help us kind of understand what this percentile stuff means, the median means you have 50% of the data below it and 50% above it, right? That's what the median is by definition. So that means it is the 50th percentile. Median and 50th percentile are the same thing. So the 25th percentile, we're going to basically look at, okay, we've got the 5 numbers below the median in our data set. And our lighting is so tough. I'm sorry, guys. I can't get a good focus and lighting. So we see 5 numbers below the median, 13, 14, 15, 15, 15. We're going to pick the number that's basically in the middle of those, because that will mean that 25% of the data is below it. We know that the median has 50% of the data below it. Great. So let's pick the number that's halfway there. That has 25% of the data below it. I drew a new arrow that says 25th percentile over the middle number of those 5, the 15. That is our 25th percentile. Now likewise, there's going to be a 75th percentile. That means 75% of the data is below that observation. So we're going to do the same thing except on the other side of the median, right? We've got the median. We've got 5 numbers bigger than that, 17, 18, 19, 20, 22. So we're going to take the middle of those, which is 17, 18, 19. There's our 75th percentile. So we now have a data set with 11 observations in it, and we've got 5 numbers that are describing that data set and kind of where it is. The minimum value, the maximum value, the 25th percentile, the median, and the 75th percentile. Now, what does this have to do with pictures? I'm going to now draw us something called a box and whisker plot. And I'm going to try using a big old crayon. No, that's not going to show up better. Box and whisker plot. So this is another type of chart we use for quantitative variables. And what we do is we're going to draw those 5 numbers that we just looked at. The min, the max, the median, but also the 25th and 75th percentile. So now I'm going to draw our number line, but I'm going to draw it vertically. I'm going to go from 13 up to 22. Again, we need to make sure we include all of our values, the min and the max, within our range. 12, so that means here. So I've got 12, 14, 16. Oh, the joys of quarantine teaching and pulling out paper and pencil and stuff just like my kids are using in their classes. Thank you for bearing with me. It got a little messy because I wrote the wrong number. But what I did is I drew a number line, and I went from 12 to 22 going vertically. 12, 14, 16, 18, 20, 22. Spacing was not perfect. Forgive me, please. Now, what we're going to do for our box and whisker plot, I'm going to write the minimum and the maximum. I'm going to have a horizontal line there. So I've got the max at 22. I've got the min at 13. I've got horizontal lines for those. Now I'm also going to draw horizontal lines for the 25th percentile at 15 and at the 75th percentile of 19. And I'm going to draw one even at the median at 16. So I've just taken those 5 numbers and I drew horizontal lines for each of them. Now what I'm going to do is I'm going to connect the middle ones. So I want the 25th percentile, the median, and the 75th percentile. I'm just connecting them into a box. See that? I took those horizontal lines I already had, just drew vertical lines to make those a box. And now I'm drawing what we call a whisker. I'm drawing a single vertical line to connect to the min and the max. So this is called a box and whisker plot. So this is describing this distribution of the number of Valentines that different kids received. And so fairly quickly I can see the middle 50% of the data between the 25th and 75th percentiles is within this box portion, and the median itself is marked with this line. And I can see where the smallest value and the largest value are. So I know that I can quite quickly see the range that this variable took. I can see where most, the most commonly occurring values are, kind of in the middle. I can also see something about the skew of the distribution. So with this one, I can see that the top whisker is a little bit longer than the bottom whisker. And I can also see that the median is lower in the box. It's not midway through the box, it's lower. So that actually indicates that there's a skew in this direction. It's like there's a tail if we were looking at a histogram. And so the tail would be going to the right because that's going to higher values, right? So the longer whisker is kind of like showing a right tail. So I'm just drawing an arrow and saying right skew, indicated by a longer whisker on one side, but also by the median being on the opposite side of the box. Because that means there's a lot of data right within this little range. It's more spread out over here. That kind of indicates that tail going out. But so there's less data in a box and whisker plot than there is in a histogram itself. A histogram is using the whole distribution to plot. With this, I only need those 5 numbers that are summarizing where the distribution is. So a box and whisker plot doesn't have as much information as a histogram, but it can be easier to look at. It can be easier to figure out what's going on because it doesn't have as much information. As we'll see, it can also be really helpful. We could have 20 of these next to each other and pretty quickly make sense of them. You have 20 histograms next to each other, that starts to get complicated pretty quickly. I mean, we actually even saw that with an example of COVID data when we had 9 histograms looking at distributions of hospitalized ICU on a ventilator. It was a lot, right? It was hard to process. That same information in a box and whisker plot, it's not going to be using as much information, but it will be more approachable. It's easier to look at fairly quickly and make sense of what's going on. So a box and whisker plot, you should practice making one. Make up a data set. Go on the internet, find a random data set. see if you can make a box and whisker plot from it using the 5 points of data, the min, the max, the median, the 25th percentile, the 75th percentile. You can also start messing around in Excel if you want to. As you could guess, that's where we'll go next. We'll have Excel help us make these, and also have Excel start spitting out the numbers that we care about, the min, the max, the median, the different percentiles, etc. All right, so that's our Friday video. I hope you guys stay safe in this icy, strange weather. I guess it's not that strange, it's February. But stay safe out there, stay healthy, and I will see you guys soon. Thanks.